Okay, let's go over lesson 3.4, part 2 of our notes. Specifically, we are going to be finding inverses of trig functions all throughout this lesson. One of the major key terms that we are going to be covering in this section is the use of the words reference angles. And right here below in this first slide, I discuss what a reference angle is. So a reference angle is always going to be a positive acute angle. And if you have forgotten what the word acute means, acute is an angle that's less than 90 degrees. So it has to be positive, it has to be less than 90 degrees. And notice in the picture below that a reference angle will always be formed with the positive x-axis and the terminal side of the angle. Terminal means the ending side, where your angle stops opening. So it must open from the beginning where this yellow highlighted line is. That's called the positive x-axis. And then the angle, we're going to call it theta sub r, is going to open up a certain distance. And eventually it's going to stop opening up at the blue line, which is called our terminal side. Since that angle is less than 90 degrees, we know that it is a acute angle. So for the sake of argument, reference angles are always found in quadrant 1 of a unit circle diagram and whatnot. So how are we going to use this term? So let's move on to example number 1. I'm going to give you a trig equation, sine theta equals negative 1/6. And I'm asking you to solve for the reference angle, all right? Now, the reference angle is going to be your theta. So my goal is to isolate theta. I need to make sure that on one side of the equal sign, theta is all on its own. So in order to isolate theta, I need to get rid of sine, but I can't just exactly delete it. So what I'm going to do is take the inverse of sine on both sides. And when I do that, in essence, the sine disappears and it is going to end up moving over. Let me get my screen to cooperate with me here. So it's going to, in essence, move over and visually. And so our theta, which we're going to call theta r because we're looking for our reference angle, is going to equal sine inverse, because now it's moved over to the right side of the equal sign. I'm solving for an angle, so that's what you always do. You always take the inverse of whatever the trig function is. And then I'm going to take the sine inverse of the quantity on the other side. Now, I want you to notice that I did not include the negative of the 1/6, okay? Even though the negative is given to me in this problem, notice this is negative here, I did not include that negative when I rewrote the equation. So what I want you guys to do every single time is I want you, if you have a trig function equals to a negative value, I want you to drop the negative, okay? For now, it's not like you're ignoring it completely, by the way. You're dropping it for this purpose. And I want you to always use positive input value when taking inverse, okay? So anytime you are going to take the inverse of a number, I want you to always make sure that that number is a positive number, okay? Always. So again, just repeating, the sign jumped over the equal sign, became a sine inverse, and the 1/6 came down. I am not including the negative. I'm just putting 1/6. So when you type that into the calculator, all right, you're just going to type it just as you see it. Make sure, by the way, I'm going to put over here, make sure your mode is in degrees, all right? So make sure your calculator is in degree mode for these problems. So when you type that out, your reference angle is going to be equal to, let's round it to the nearest tenth, it's 9.6 degrees. So type that in your calculator and make sure you get 9.6 degrees. All right? Okay. Now, the next section, the next question for this same problem is we need to find two possible quadrants that this angle could lie in, okay? Now, here's the thing. We have 4 quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? And I need you to determine which 2 of these quadrants will satisfy this equation, sine theta equals -1/6, okay? So in this equation, you will notice that our sine trig function is a negative number. That's what it says. Sine theta equals -1/6. So keep that in mind as I'm going to teach you something new. So on your formula sheet, if you guys look at your formula sheet, you are going to see in the upper left-hand corner towards the middle, there are these 4 letters in a little box. And they have the letters A, S, T, and C. All right? Now, if it's hard to remember those letters in those quadrants 1, 2, 3, and 4, again, these are quadrants. Let me rewrite those over here. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, okay? If you can't remember those letters, you can use the acronym all students, take calculus. If you remember this phrase, you will always remember those 4 letters, okay? All students take calculus. So anytime I'll allow you guys to use the formula sheet, but let's say my honors students, if I was teaching honors students, I would not allow them this formula sheet. So the way they would remember is they remember the Roman numerals 1, 2, 3, 4, and then they will remember the phrase all students take calculus. Now, what do those letters help us for? Okay, so here's what they help us for. This little rubric here tells us where our trig functions are positive. Okay? Positive. It tells us where our functions are positive. So here's how it works. Let's say your question is, so here's question number 1. Where is sine positive? Okay, where's my sine function positive? Well, the way you will tell me that sine is positive is the letter A tells me that sine is positive in the first quadrant because A stands for the word all. All the functions, all 6 trig functions are positive in the first quadrant. So the first answer would be, where is sine positive? In quadrant 1. And then there's another place it is positive. Well, sine starts with the letter S. So this quadrant will be the other quadrant sine is positive in. So that's going to be quadrant 2. All right. Now, here's another question. Question number 2. Where is tangent positive? Okay, where is tangent positive? So I'm going to erase this and this a second. Okay, and so, whoops, drop my pencil. So we have all students take calculus. Where is tangent positive? Well, tangent's going to be positive is going to be positive again in the first quadrant because all the functions are positive in the first quadrant. So again, I'm going to put 1. And tangent is positive in the third quadrant. Why? Because the third quadrant has the letter T, so it's positive in the third quadrant. So 1 and 3 is that answer. Next question. I think you probably are getting where I'm going with this, right? Notice every question was positive. Where is it positive? Where is it positive? And the last one, where is cosine positive? Well, let's erase again. Erase, because these were the answers to the previous one. All right, let me put my letters. All students take calculus. All right, so where's cosine positive? Well, cosine's definitely positive again in the first quadrant. And C for cosine means fourth quadrant is the answer. So 1 and 4. Okay? So that's how you use this rubric. Anytime you want to know where the functions are positive, you would just shade the first quadrant and then the letter that your trig function begins with, okay? But here's where the tricky thing starts, where students start getting confused, okay? So what if I, instead of using the word positive, and I say, where is sine negative? Okay? Where is sine negative? So here's where I want students to understand what you're going to do, all right? So let me erase the answers here again. Let me erase this again. Let me put those letters back. All students take calculus. Okay, if I ask you where is sine negative, if you told me that sine was positive in first and second quadrant, you see those blue ones? You told me sine was positive here in the first quadrant, and here in the second quadrant. If I'm asking you where is sine negative, that means you are going to tell me the other quadrants, which are the ones that are not highlighted. So the ones that you don't highlight are the answers for negative. So negative, the answer would have been 3 and 4. Okay? Where is tan positive? In first and third. So if I said negative, where is it negative? You wouldn't tell me 1 and 3. You would tell me the other quadrants, which is 2 and 4, the ones that you didn't highlight. And the same thing with cosine. Where is cosine negative? Well, if it's positive in first and fourth, negative would then be the second quadrant and the third quadrant. Okay, so I hope that makes sense. So those are the only 6 questions, the 6 combinations of answers that you can have. So why did I show you all of this? Well, let's go back to this question. Okay, so I have my little rubric here of my quadrants, and let me put my letters. All students take calculus. Okay, I need to know what are the quadrants my specific function could lie. Now, my function was sine theta equals -1/6. So if that's my problem, I need to ask, where is sine? And then notice this number is negative. Where is sine negative? Well, I know that sine is positive here and here, right? That's where sine is positive. So negative is going to be where? The ones I didn't shade. So my answers, where is sine negative, would be quadrant 3 and quadrant 4. And I'm done. That's all I need you to do for that one. Okay? So whenever you're taking the inverse of a function, make sure that the the quantity that you are taking the inverse of is always positive. I need you to drop that negative, okay? And then when you're doing your quadrants, find out where they're positive, and then you can give, if they're asking you for positive, take that back. If they're asking you where are your trig functions negative, look for the positive ones, and the ones you don't shade are your negative, and that's what we did on this one. So what I need you to do now is come over here to example number 2, pause the video, and work this problem out. Okay, so if you're back, what you should have done is to find your, first of all, reference angle. So your reference angle just meant that you took that cosine and you moved it over to this side and you wrote cosine inverse. Please don't say cosine -1, cosine inverse, and you took the square root of 40 over 8, and you made sure to drop that negative, right? So no negative, just ignore it. And when you typed that out, your theta r, your theta r, or your reference angle rounded to the nearest tenth, is 37.8 degrees. So this was your first answer. All right. And then you were to find the quadrant location. So let me just draw a little picture here. Goodness. All right, so here's my little quadrants here to give us a visual. All students take calculus. All right, so my equation is cosine theta equals negative square root of 40 over 8, right? So what is the question I need to ask myself in order to determine the quadrants? So there's my trig function. So where is cosine? Okay, since I'm asking you what quadrants, what is the location, that's a where question. Where is cosine? And this number, is it positive or negative? It's negative. So where is cosine negative? Well, first of all, we know cosine is positive where? Because remember, this rubric here has to do with positive values, okay? Cosine is positive where? Cosine is positive here in the first quadrant, and here where it says C. That's where it's positive. Yellow means positive. So where is it negative? Negative is in this quadrant and in this quadrant. So 2 and 3 is what you should have answered. Okay? All right, so let's take this up a notch. Now, what are we going to use this information? We're going to use it to finally find the solution to our equations. So find all the angles anywhere from 0 to 360 degrees. Notice that it's less than, not less than or equal to, so you're not including 360. So right up to 360, don't include it. So 1 revolution. Find all the angles from 0 to 360 that satisfy this equation. So I'm going to walk you through example 3, and you're going to end up doing example 4, okay? So as usual, in order to find all angles, the first thing you're going to do is find your reference angle, theta r. Theta r means take the inverse of your trig function, and the inverse of this trig function is tan inverse, and then the quantity. Make sure your quantity is positive, and in this case it is. So theta r equals tan inverse of 7/3. When you take the tan inverse of 7/3, theta r is going to be, let's see here, 66.8 degrees. So type that out in your calculator, and this is our reference angle, okay? That's theta r. Now, let's find out the quadrants, okay? Let's figure out what quadrants we've got. Now, I'm going to make our little rubric here again. And we have all students take calculus. Now, what's my question? My question is, this is the trig function. Where is tangent? And then I look at this number. It's a positive value, so I say positive. Where is tangent positive? So I take my shading. It's always positive here, so we'll always permanently shade the first quadrant. Tangent starts with the letter T, so it's here. Okay, so that's where it's positive. And that's all I have to do. I stop there because they asked for where it's positive, not negative. So my answers are where I shaded. That is quadrant number 1 and quadrant number 3. Okay, so there is that. All right, so quadrants 1 and 3. So once I find those quadrants, you are going to be able to find the angles that satisfy the equation. What I want you to do is you are going to find theta in first quadrant, and you're going to find theta in the third quadrant, because those are the two quadrants you told me your answers were in. Now, go into your formula sheet. Where do I have that? Nope, I don't have them anywhere here. Okay, so you're going to have to go to your formula sheet because I did not write these down. But I'm going to go back. You know what? I'll come over here a second. Let's come over here, and I'm going to erase all this. On your formula sheet where you have this rubric here, okay, there was some additional writing that I forgot to put here on my notes. So I don't know why I don't erase the whole thing. You know what? Hold on. There's a clear slide here. Erase all strokes. So here is, I'm going to recreate what's on that formula sheet, okay? So on your formula sheet, you have the all students take calculus, but inside that, there are four formulas. The first formula was a theta. On your worksheet, would you please put a little R there, because I did forget to put that. On the second quadrant, there was 180 minus theta. Also put an R there. On the third quadrant, there's 180 plus theta R. And on this one, the formula was, I'll write it right here, 360 minus theta. Also put an R. So I need you to focus on these 4 formulas, okay? Quadrant 1, 2, 3, and 4 each have a formula in it. Now, that's what we're going to do right now. So those formulas is what we're going to use, and this is what I'm talking about when I'm talking about the problem we're doing, okay? So let's go back to our problem right here. So for quadrant 1, we said that the formula required us to find theta R. Quadrant 1, there was only theta R. So theta 1 is going to be theta R, and theta R is just what we found just now, 66.8 degrees. That's my first solution in angles, okay? And it does fall between 0 and 360, so I'm good, all right? Theta in my third quadrant requires me to do 180 degrees plus my reference angle. So I'm going to substitute 180 plus my reference angle is the 66.8. So my theta R is going to be, when I add those two together, 180 plus 66 is 246.8 degrees. And that's my second answer, which also falls between 0 and 360. Okay? And both of these are the formulas that I got off that chart. Okay, that's for the first quadrant. That was for the second quadrant. The third quadrant. Okay, so let's go on to the next problem. In this next problem, I want you to pause the video and work this one out on your own. Okay, so what did you do to do this one? Okay, the first thing we do is find theta R. So theta R is tangent inverse of whatever the number is, but make sure your number is positive. And when you take the tan inverse of 3 over 2, what did you get? The tan inverse of 3 over 2 is 56.3 degrees. Okay, so keep that in mind. That's an important piece of information. Now we do the quadrants. Okay, we write down the equation that we need to ask ourselves. And we're writing it down for notes. You can just keep it in your head. But that's the trig function. Where is tangent? And what is this number? Negative. Okay, where is tangent negative is our question. So here's our visual. All students take calculus. And we shade where it's positive. Always shade the positive. So it's positive here and it's positive here. But the question asked, where is it negative? So what are the answers? Our quadrant answers are going to be 2nd and 4. So these are where our answers for our angle is going to be. So theta 2 is going to be the formula. Look at your formula sheet. It's going to be 180 minus theta r. Theta 2 is going to be 180 minus the 56.3. And what do we get when we do 180 minus 56.3? We get 123.7. So there's my first answer. It falls between 0 and 360, so I'm good. And then I do it again. My second angle is found in the 4th quadrant. The formula for 4th quadrant, go to your formula sheet, and it was 360 minus theta r. So I substitute my theta r, which I found earlier, 56.3. And so 360 minus 56.3 is 303.7 degrees. And I'm good there as well. Okay. Alrighty, we're almost there, folks. Next problem, example number 5. Now, for these last 2 examples, you actually are not going to use any unit circle, no calculator, because these problems involved common angles, okay? And common angles are the angles in our unit circle of 0, 30, 45, 60, 90, all these right here that I'm talking about, okay? In degrees at least, okay? Now, they want us to find all angles that satisfy this equation. I do not want you using calculators. So in your Delta Math, you're going to see a section called Common Angles. Practice, do not use calculator, okay? So you need to first find the angle, all right? The reference angle, just like we've been doing. Now, theta r is equal to, now, you're accustomed of doing this, cosine inverse of square root of 3 over 2. Okay, that's not wrong. That's not wrong notation, but I don't want you to use the calculator. What I want you to do is go over here to your unit circle, and you are going to find theta r by only focusing on this section of your unit circle. This section right here. Okay, I'm blocking it off. You see the first quadrant? That's the only section you need to pay attention to. Why? Because my reference angle has to fall between 0 and 90 degrees. So that means that the only angles you need to worry about are 0, 30, 45, 60, and 90. You don't have to pay attention to any of these other ones because those are not acute angles. So like literally, if I had a white, I think I can possibly do this. Let me do this. I'm literally going to do this. I do not want you paying attention to any of this. You see? I am literally telling you, ignore the rest of the unit circle. Because when you're looking for a reference angle, all we care about is those angles that are between 0 and 90. Okay? So let me go back to my here. Okay. So let me erase these right here. Now, the question in our problem was, which angle is going to be cosine inverse of 3/2? So if you look at your formula sheet, cosine is equal to x, all right? Cosine is my x value, all right? So going over here, remember here, cosine is equal to x. You're going to look at the x values where it is equal to square root of 3/2. Which one of those has a square root of 3/2? Well, we definitely notice that on this dot right here, this one definitely doesn't have a square root of 3/2. This one over here has a square root of 3/2. This one doesn't, this one does, and this one doesn't. So the only answers that we possibly have is this angle right here and this angle right here. But because our square root of 3/2 has to be an x value, it has to be this one, because this one here is a y value. So this answer is our answer, the 30 degrees. Okay, 30 degrees is our answer. So I'm going to come back over here. Theta r is equal to 30 degrees. That's our reference angle. So no calculator was used right there, all right? So then what do I do to find the two other angles? Well, I need to ask myself what quadrant, right? And again, all students take calculus. My cosine is a positive number, so I'm going to ask myself, where is cosine positive? Well, cosine is positive here and here. So my quadrants are 1 and 4. So I have to do theta 1 just says whatever your reference angle is, that's the answer. So 30 degrees is my first answer. And then theta 4 says 360 needs to subtract the reference angle. Theta r, I guess I should write that down just in case you don't remember using the formula. So 360 minus the 30 we found is 330. And that's your other angle. And both of these fall between 0 and 360. And you're done. Okay? So when you're finding angles using common angles, again, let me repeat what I'm saying here. You please notice that you only have to choose from 5 angles. Your angles are either going to be 90, and that's covering it up, so let me not use that. Your angle choices are 90, 60, 45, 30, and 0. You have 5 choices to choose from. You have a 20% chance of choosing the right one. And we chose 30 because the x for cosine was square root of 3/2. Okay? So let's do this next one. Last one. Tangent of theta equals square root of 3. No calculator, okay? Let's do no calculator on this one. Practice using no calculator. So the first thing we need to do, theta r equals tan inverse. Oh my goodness gracious, my key is not wanting to work. Tan inverse of square root of 3. All right? Now, again, we're not using the calculator, so I don't want you typing that out. I want you going to your unit circle. All right? Now, again, to make it a point, let me redo what I did last time. When you're using the unit circle and you're looking for angles, we are not looking at anything else in our unit circle. nothing else. We are only looking at a reference angle, and reference angles are less than 90. So again, I'm erasing everything because I just need you focusing on those 5 angles. So one of those angles is my answer, okay? Now, here's what I want you to realize. Process of elimination helps so much. I'm looking for the tan inverse of square root of 3, okay? Notice it says square root of 3. And so when you look at your unit circle, the only ones that have square root of 3 in it are this angle and this angle. So it's no way it's going to be the other one. So right off the bat, I can eliminate 90 degrees. I can eliminate the 45 degrees. I can eliminate the 0 degrees. Those are not possible answers. So I'm down to 50-50. So if the 5 choices eliminate, it's either 30 or 60. And tangent, going back here, what does tangent mean? Well, tangent means y over x, all right? Y over x. And we wanted the y over x to equal square root of 3. That's your problem, see? Square root of 3. That's what we want y over x to be. So which one is going to give us square root of 3? Well, let's try the first one. This is my x, this is my y. We're going to try it at 60 degrees. So at 60 degrees, y over x would be, y is square root of 3 over 2 over, and my x is going to be, I didn't mean to do that. My x is going to be 1 over 2. And square root of 3 over 1 over 2, those 2's cancel, and I end up with square root of 3 over 1. And look at that. Square root of 3 over 1 is square root of 3. That's what I wanted, right? So I pretty much found my answer. There's my answer. I'm done. Just in case you don't understand why the other one's not the answer, let's do that. It's, oh my goodness, let's do at 30 degrees. The y in this one was 1 over 2. The x is square root of 3 over 2. But when I cancel out the 2's, I end up with 1 over square root of 3. But 1 over square root of 3 requires you to rationalize. And I end up with square root of 3 over 3. That is not the answer I wanted. I wanted just square root of 3. So again, 60 is my answer. So I come back over here. I'm done. 60 degrees. I did not use any calculator. Then I need to decide what quadrants are my answers in. Let's try that again. There's that one. There's that one. All students take calculus. All right, so what is my question? My question is, where is tan positive? So tangent is going to be positive here, and it's going to be positive here. That's where tan is positive. So quadrants what? That is quadrant number 1, and in quadrant number 3. So my 2 answers are going to be theta 1, which we already know is always just theta r, which we found out to be 60 degrees. So we're done there. There's my first answer. And then theta number 3, theta in the third quadrant, the formula for that quadrant is 180 plus theta r. So it's going to be 180 degrees plus my 60 degrees, which was my theta r. And so my second angle is 240 degrees. And both of those angles fall between 0 and 360. And that, my friends, is lesson 3-4, part 2. Hope this helps. Let me know as usual if you have any questions. Thanks for watching.